17. It's this question, which is about a series and sums. So let's get straight into it. We'll do the first part first, obviously we'll ignore down here for now. Let's just do this part. Now, in case you're not quite familiar with this notation here, what this means is you start with r as minus 1, you do this thing to it, so minus 1 squared, and then you go to r as 0, and you do that. And then you go to r as 1, and you do it, and you add up all the results until the last one, which is n squared. So that's kind of just what this means. You've probably seen it before in A-level. Now, what they're saying is we can write our expression we've been given in this form, in this kind of polynomial, this cubic form, right? So let's see what happens when, let's say, n is 2. So let's put n is 2 into this side. Now, if n is 2, that means we do this thing and we stop when we reach 2. So we have minus 1 squared plus 0 plus squared plus 1 squared plus 2 squared is on this side here. Now, if n is 2 over here, you just put n is 2 in, right? So you get p times 2 cubed, q times 2 squared, and r times 2, and you end up with this here. So that, be careful, is a positive 1, plus 1 is 2, plus 4 is 6, and that's an 8p, that's a 4p, that's a 2r. Now, just be a tiny bit careful here. This r has nothing to do with this r over here, right? These r's are not related. This r is kind of like it's called a dummy variable. It's just used in the sum, has no relation to anything else. But it was a poor choice for them to use the same letter there. But it doesn't have anything to do with it. So this is our first equation, and I'm going to tuck it up there. And now I'm going to use different values of n. It tells me by setting n is this. So I started up at the top here. Let's use n is 1 next, right? So this time, on this red one, we're only going to go up to 1. So we're going to start at minus 1, as we always do, and we're going to stop at 1. So that's the red bit. And over here, we're just going to put in minus 1s here. Now, we're going to put 1 into here, which gives us p plus q plus r plus s. And this side is going to be 1, again, plus 1 is 2. And that's our second equation. We'll tuck it up there. Next, we'll use n is 0. Now, when you use n is 0, on the sum, you only go minus 1 squared and 0 squared. And over here, you use zeros in here. Now, this is really nice because that means all of this goes away. And I'm just left with s equals 1, which is going to be very helpful. So s equals 1, tucked away up there. And lastly, by setting n is minus 1, now on the sum, this is a bit weird. We're going to start at minus 1, and we're going to finish at minus 1. So we're just going to have this term here. And over here, we're going to put minus 1 in. This is a bit clunky, this kind of brackets I've done, but hopefully we all know minus 1 cubed is minus 1. So that's going to be a minus p. That's going to be a positive q, because as we've seen, minus 1 squared is positive 1. That's going to be a minus r, and that's going to just be s. And that's our fourth equation. And here we have a system of 4 equations with 4 unknowns, which means I think I can solve that. Even better, I've been given s as 1, which means immediately these 3 equations here can just turn into, if I replace a 1 there, because that's what s is, I can do that, put s as 1 there, and put s as 1 there. And now I can simplify these, right? So I can take 1 away from this equation there to get a 5 there, so I've just simplified that equation to get here. Take away 1 from here to get that, take away 1 from here to get that. And now I have 3 equations with 3 unknowns, which I know I can do. So I'll put those at the top here, make a mental note that s is 1. And now here, I notice that I've got lots of matching coefficients. So let's just deal with these 2. Ignore the top one. Let's just deal with these 2. Let's add them together. 1 plus 0 is 1. These 2 cancel. This is 2q. These 2 go away. So I'm left with 1 is 2q, and q is a half, which is great. So that's my second one. I've got 4 to find, and I've got 2 of them already. Now, if I take this one here and just put q as a half into it, 4 times a half is 2. And then if I take this one here and put q as a half into it, I get 1 plus p plus a half plus r. Right? And now I could put q as a half into this one as well. But at this point, I notice, well, because I found 2 unknowns, I only have 2 more to go, which means I only need 2 equations. So this is kind of irrelevant now. I only need these 2. I can do it just with these 2. So if I take this one, for instance, and double it, double that as 2, double that as 2p, double that as 1, double that as 2r. Well, what do I get? Well, I have my matching r's now, so I take these away, get 3, 6p, 1, nothing, rearrange, solve. And I get p as a third. So that's 3 of my unknowns found. Only 1 to go, which means I only need 1 equation. Pick your favorite equation. I think this one is probably the easiest one to go with. If I rearrange that just a tad, add r to both sides, I get this. And now r is the thing I'm looking for, and I know p and q. So I get r is minus a third, plus a half. And if you do that, you find that it's a sixth. And those are my 4 unknowns all found. So going back to what we had that this sum here was equal to this cubic with those 4 unknowns. Well, I know them all now, so I'm just going to put them in. I know p is a third, I know q is a half, and so on. Okay, what can I do now? Well, I noticed looking at the front here, looking at the thing that I'm trying to get, and there's a sixth out here. So what I'm going to do is I'm going to take a sixth out of this. Now, it doesn't look like I can, but I definitely can. I'm going to take a sixth out and leave behind. Now, to make a third NQ, I need a 2 here, because 2 times a sixth is a third. To make a half n squared, if I've taken a sixth out, I need 3 of them in here, because then 3 times a sixth is a half. And this one's the clear one, right? Take a sixth out, that just leaves 1 behind. Now, notice how the bracket ends there. I'm just leaving this one alone. Right, I don't really want to take the sixth out of that, and I'll explain why in a second, but I'm leaving that one alone. Now look at this here. I also need to factorize out an n apparently, which is sort of why I had the feeling that I wanted to leave this one alone here, because I can factorize out an n of that, right? I can take the n out there. And furthermore, now what else do I have in the bracket here? Well, actually, looking at this, I think that factorizes into that, right? I think this factorizes perfectly into that. 1 times 1 is 1. That's a 2n, that's another n, so that makes 3n, and then of course a 2n squared. So I think that factorizes perfectly into that. So what I've done here is I've got this question absolutely bang on, except for this one, right? Except for this, right? I have nailed this question except for this +1. Everything is perfect except for this +1. So what's gone wrong here? Like, where have I made the mistake? And the answer is I haven't. I just need to notice that the thing that they're trying to ask me to get is not the thing that they've given me. The sum that they're asking me to get starts at a different point. They've been really cheeky and started the sum at a different point to the one I've been using. So what do I do about this? Well, I remember what this sum actually is. This sum is the sum from -1 squared up to n squared. And I've colored this in red because the sum starting at 0, the one they want, starts at 0 squared and goes up to n squared, which means this sum, the one that I have and don't want, this sum is -1 squared plus this sum, because this sum is just all the red bit. So this sum here is -1 squared just then plus the red bit. So I can get rid of this now. I can get rid of this here and replace it with what I know it is, with that first term that's missing from here and then just the rest of it. Right? And now this here, -1 squared, we've seen that is +1. And now, of course, I can just cancel the ones on either side or take away one from both sides. It doesn't really matter how you say it. And you get exactly what is required. Okay, so part 2 of the question, classic step businesses, is basically the same question. It's just a little bit tougher. So again, we'll start out by saying, apparently, this sum here, starting at -2 this time. Now, maybe note here, starts at -2, but the thing I'm eventually going to have starts with a 0. So I'm going to have to pull the same trick at the end, but I'll worry about that later. So we have the sum starting at -2, and apparently that can be written as this polynomial, this quartic here. Okay, so my first job should be to try and find a, b, c, d, and e, just like I did on the first part. And to do that, they haven't given me the hint this time, but I'm going to start using values of n. So let's start with the most basic one on this side. Let's start with n is -2. So all I've got on this side is just, I'm going to start at -2, end at -2. So I've just got the -2 cubed. And now I put -2 into all of this. And now the -2 to the even powers are going to be positive powers, and the -2 to the odds are going to be negatives. So I end up with this here. And that's my first equation, going to tuck it away up there. And I'm now going to move on to what if n is -1. And I'm just going to do this quite a few times until I have enough equations. And how do I know when I have enough equations? Well, I follow the golden rule, right? I need 5 things. I need 5 unknowns, which means I'm going to need 5 equations. So I'm going to do this 5 times. Let's try n is -1. So on this side, I go from -2 cubed plus -1 cubed. That's all that's on here, because I stop at -1. And here I put in the -1s. Again, the even powers make positives, and the odd powers make negatives. So that's my second equation. Third equation, this is going to be the gorgeous one when n is 0. This side is going to be -2 cubed plus -1 cubed plus 0 cubed, but this side, all of that is going to go away. Just left with e. This makes -8, -1 makes -9, so e is -9. And that's great because I get a whole variable for free, just like last time. What about n is 1? So here I'm going to add up 4 things, going to stop at 1. Here I'm going to put 1s into all of these, which is just going to give me the coefficients because all of this is just 1. And I'm left with this. And I put that up there. And I need one more equation because I've got 5 unknowns, so I need 5 equations. So the next one, I'm going to try n is 2. Add up all the way to 2, put 2's into here, and you're going to get the powers of 2's as coefficients. I think you end up with this. So it's kind of nice that all this cancels. That might be helpful to make a 0 there. But those are my 5 equations, right? Which means I can stack them here. Highlighted this one red because it's the one I can use straight away. If e is -9, then I can just take all of these equations and put -9 into them as e. Notice I'm going to save myself some time here. This is a -9 now. Add 9 to both sides to make this a 1. Right? And this one, this is a -9 now. Add -9 to both sides and make this a 0. So I'm just saving myself writing stuff out. This is a -9, add 9 to both sides, that becomes a 1. This is a -9, add 9 to both sides, that becomes a 9. So just pause the video if you just need to catch up with that, but I've just done a couple of stages of working in one go. Now, why have I put these blue and these red? Well, I noticed the coefficients of these two line up nicely, and the coefficients of the green two line up nicely as well. So I'm going to separate those out into this pair and this pair, and I'm going to take away. Or in fact, I'm going to add, apparently. Now, I think I could have probably done either, but I'm going to add. 1 plus 0 is 1. That's 2a. That goes away. That's 2c. That goes away. So that's the correct equation. We're right here. This time I'm going to add as well. That becomes 10. That becomes 32a. That goes away. That's 8c. That goes away. And now I have 2 equations in 2 unknowns. This is just a simultaneous equation, an a and c, isn't it? So I can solve that. I can times this one by 4, I think, to match the c's. Take away. 24a equals 6. Divide by 24, a is a quarter. So I've found my second variable. I've got 5 to do. There's the second one. A is a quarter. So let's now return to those original equations I had without the e. But now I know that a is a quarter. And again, I'm going to do this quite quickly. If a is a quarter, then this is 4. 16 times a quarter is 4. Take away 4 from both sides. That becomes a -3. Now, if a is a quarter, I can take that away from both sides to get minus a quarter equals this. But I don't like fractions, so I'm just going to times everything by 4. Minus a quarter times 4 is -1, and all these just have 4's in front of them. I'm going to do the same thing to this, right? So that's a quarter. 1 minus a quarter is 3/4. Times it by 4 for 3. And then all these have 4's in front. Just pause the video and make sure you can get to there if you're a bit behind. But those are my 3 equations. Now, I'm going to stop there because I have 3 unknowns. So I know I only need 3 equations. I don't need to do it with this. I could find out what this is without the a, but I don't need to. 3 equations should be enough. I noticed that these equations match up. The coefficients match up nicely. So if I just take these two and put them down here, and if I just add them together, that goes away. That becomes an 8c. That goes away. So 8c is equal to 2, and c is a quarter. And I get my third variable. And the variables are going to come thick and fast now. Because, again, coming to my 3 equations that I had last, so I'm just going to take these 3 equations, write them out again, but this time I'm going to put a quarter into them as c. Now this is really nice, right, because these are all 4's, which means all these are just going to come 1's. And then, so this is a 1 when you do 4 times a quarter. Take away the 1 from both sides, that becomes a -4. This is a 1, take away 1 from both sides, that becomes -2. And again, could do it to this, but I only need 2 equations because I only have 2 things left to find. Okay, so here's my simultaneous equation. It's the last thing I need to do. Let's times that one by -1 because I don't like negatives. And let's times this one by -2 because I notice if that gets times by -2, it'll match up with the 8. All right, now let's actually subtract them this time. 0 equals 0 minus 6d. d is 0. So that's my 4th variable. 4 out of 5. At this point, I only need 1 equation to find the last variable. So let's just use this one. Put d as 0 into there. 4 equals 8b. Divide by 8 to get b as a half. And those are my 5 variables. And that's the bulk of this question out of the way. It's going to wrap up pretty quickly now. Here are my variables. Going to put them in alphabetical order because I'm feeling fancy. Now let's go back to the original problem. It was saying that this thing here with the -2 is equal to this polynomial. But I know what all of the coefficients are now. They're all of these things. So let's put them in. Notice how this d goes away. So the last term is an n squared. because that goes away because that's 0. Now I'm going to do the same thing I did before. Like, I'm going to notice there's a quarter here, so I'm going to factorize out the quarter, but I'm going to leave the 9 alone because 9 wouldn't factorize that nicely anyway. So a quarter taken out of this. And also, I need an n squared. So if I had brought the 9 along in that factorization, I couldn't take out an n squared, whereas I can take it out from here. All of these have an n squared to factorize out. So I'm going to take it out. And now look at this here. I think, again, this factorizes into n plus 1, n plus 1, which is n plus 1 squared. So I think, again, just like 10 minutes ago, I have everything perfect except for this minus 9. And we really discussed, I think you can tell what the problem is. The problem is this thing here, right? So we're going to pull the same trick we did last time. This here, starting at minus 2, is minus 2 cubed plus minus 1 cubed all the way up to n cubed. But I want to start at 0. I want this thing here. But that's okay, because the thing I don't want is just these two terms plus the thing that I do want. Right? So I'm going to replace this thing here with this thing here in my equation. I'm going to replace that with that. And now minus 2 cubed is minus 8, minus 1 cubed is minus 1. Put those together for minus 9. And then, of course, either add 9 to both sides or just cancel out those minus 9s. And I end up with what's required. And that's the whole question. So yeah, I really enjoyed doing that one.